All right, let's get started. My name is Michael. I'm co-founder and CTO of Boltz. And what we do and why we do it, that's the topic of today. But at first, I want to start with a little primer on what even is Lightning and just quickly reiterate the concepts. So Lightning is the first layer 2 network on Bitcoin, and it's a network of payment channels. And when thinking back to the early days of Lightning, when it was first conceived in 2017, 18, post the block size wars, it was praised as this one solution that will solve all of our problems. It's going to be perfect for everything, and we're all going to use Lightning and be happy. And while the vision came true, it's an actual trustless layer 2 on top of Bitcoin. The reality today looks a little bit different than what was anticipated back in the day. So just to quickly reiterate of how Lightning works. I have a little diagram of a payment channel network. In our case, it's a really small one of Alice, Bob, and Carol. These are 3 Lightning nodes which have a channel with each other. There is one channel between Alice and Bob and Carol. In the scenario of Alice trying to pay Carol, we have the so-called routing. As in, Alice creates a so-called HTLC. What that is exactly, we'll get into details later, but it's basically a payment on Lightning. So Alice sends a payment to Bob. In turn, Bob sends a payment to Carol. So you create a route across the network to get to different destinations to which you're not directly connected to. That's the whole principle of Lightning. A network of payment channels which you can use for your payments. Without having a direct connection, you can do multiple hops across the public channels of other people. And with that, we have basically the whole idea of Lightning. Sounds simple enough, but due to the limitations of what the Bitcoin main chain can do and how exactly this thing works behind the scenes, there's a couple gotchas, especially in the context of mobile wallets. This Lightning thing works amazingly well if you have a server that's super powerful, has amazing internet that never faults, that never fails, and disks that are immaculate, RAID, and backed up every hour all the time, then Lightning is amazing. But when looking around at how people use Bitcoin, it's not at home SSH'd into the server using some weird CLI tool. It's different, and it's especially on mobile. Mobile users are like the main area where people use Bitcoin, where people have their coins, where people use wallets. And when you have Lightning on mobile, there are a couple issues, and 4 of which I'm going to get into a little bit of detail today and elaborate on. These 4 issues are the chain sync, the public channel gossip and the sync of that, backups, and liquidity. In the early days of Lightning, people were trying to put these Lightning network daemons into mobile apps. That didn't work out, and pretty much everyone who tried that is now defunct, and it's pretty much dead. Didn't work out at all. This is a screenshot from one of the early Lightning wallets that were on mobile. It's from Lightning Labs, was called Lightning Mobile. And when you did install that thing, your phone turned so hot, it was literally, you could watch it drain the battery. And that didn't work at all. The first reason for that is Lightning is a Bitcoin layer 2. It builds on top of the Bitcoin chain. And when you interact with the Bitcoin chain, when you need data from it, when you need to react to things happening on the chain, you need to get the data of what's happening. Channels are created by sending transactions on chain. You need to see that transaction. It was actually sent. It's actually confirmed X number of times. And is my counterparty trying to cheat me? You need to be able to get that data reliably and to react to it accordingly. Without reliable chain data, you are basically screwed, even when using the layer 2. So what options do you have on a mobile end client to get chain data? You could run a full node, which is obviously not feasible because even if you were pruning it and deleting old blocks, you don't want to open your app and sit there syncing for half an hour, so that's not an option. There were some inclinations to develop new kinds of light clients, namely the BIP 157, which is a relatively lightweight client-side filter for which transactions are in a block. But even that one is just too slow and cumbersome to use in a mobile setting. Because imagine you are at some conference trying to pay for coffee, but you get a bad peer-to-peer connection to the other Bitcoin nodes. Your light client sync takes a minute or two or even 30 seconds. It's a horrible experience. So in the end, everything gravitated to the Electrum protocol, where you basically send one request to some server of like, hey, please give me the transaction history of this address, and responds in a really simple way. And so basically we already make huge trust assumptions of the security of the entire layer 2 by using a trusted Electrum server in the mobile Lightning wallet, which is already not great. And that's just the bottom of the stack of the whole Lightning experience on mobile. The next big issue is also sync, where you have the gossip. When you want to send a payment on the Lightning network, as we had it earlier, you want to route through other people's channels and use them for your own payments, because you won't be connected to every node you want to send to. So you have this public channel, so-called gossip, which is basically announcements where every node on the network willing to offer their channel to you for routing through to your destination announces itself. And when you want to see the entire map of different channels available, you have to download that, which you can kind of imagine like a torrent, where you have a bunch of nodes on the network, you connect to them, and you can download the essentially same data from different people, because it's supposed to be one uniform graph of channels and nodes out there. And you can imagine there's similar problems to downloading the chain or just chain headers or light client filters of you need to find someone on the network that serves you the data peer-to-peer in a fast, reliable, and quick way. If you just connect to some arbitrary node out there, which could be someone in their mom's basement just surfing that gossip, it could be super flaky and unreliable, which again is a horrendous experience in the I wanna pay for my coffee right now setting. It's just not feasible. And also imagine the scenario of having your wallet offline for a couple weeks, and then you have to sync the entire backlog of what happened since then. Horrible experience. And people try to work around that by having a thing called rapid gossip sync, which basically you can imagine like someone aggregates the entire updates and gives you one big package of everything that happened in the meanwhile while you were gone. Also introduces some assumptions of someone being willing to do that, but in the end, everything that still runs a normal, real Lightning node on a mobile setting uses a thing called Trampoline routing, which effectively means that your phone, even if it's a true Lightning node, doesn't use the gossip, doesn't even know of the other nodes and public channels that exist on the network. It simply delegates that function in a sense of, for example, the amazing Phoenix wallet by Azonk. It doesn't do any pathfinding routing gossip on the phone. It simply has its service provider to which it tells, here's an invoice I want to pay. This is your fee budget. Please do it on my behalf. So basically, this is the next thing where to make a usable experience work, there's trade-offs to be made. And if you want to have any good experience at all, you have to not only outsource the chain sync, but also the gossip and routing to a third party that just does it on your behalf. This third party here, even in the Trampoline routing example, is not trusted. There is no custody, but it's still a trust assumption that they act in good faith. And it's a service provider, as in theory, it's an open standard. You can switch to alternatives. But usually, by default, it's just this one service you use over and over again to get a good, reliable experience. The next big issue, that even assuming all of that, we use our trusted Electrum server that works super reliably and fast. We have our Trampoline routing to outsource the pathfinding and gossiping to. Next issue we have, backups. In Lightning, you have these payment channels, which are basically updating its state of who owns how much of the channel incrementally every time something changes. For every payment you do, there is a new state update. For every fee update that happens on chain, there's a new state update. And it's like an append-only database where you also have to store all previous updates. And if you ever happen to lose the latest update, your money is gone. Which is a pretty horrible scenario. Imagine you have some end client, some software you ship to end users, and they lose all their money because, oops, backup didn't work. That's a pretty horrible scenario. And it's really rough to work around, because even assuming you have cloud backups and you let people back up their channels to Google Drive or an iCloud account, what if that backup fails with flaky internet, they restore on a different device, and oops, all their money is gone? Which is just a scenario you can expose people to. It's like a real threat that every Lightning implementation and application faces every day. You cannot ever mess up saving the data correctly, else you're screwed, and there is no way of recovery. Even neglecting that, even assuming you have the perfect backup strategy that never ever fails, one of the root issues that you always have, you have ChainSync figured out, you have a Trampoline that routes all your payments, you have the perfect backup. The next thing that comes to haunt you is a thing called liquidity. In these payment channels, you have, let's say we have a channel of 1 Bitcoin. One side opens that channel, which means they have 1 Bitcoin now on their side. When they send out payments via that channel, the balance moves to the other side, meaning that only the balance you have on your side of the channel you can send out, which is fair enough. You can't spend money you don't have. The tricky part is, which is a real alien concept for pretty much everyone because Lightning introduced it, you have to have balance on the other side of your channel to be able to receive. Meaning that if you open channels to people, you can't receive a single Satoshi. You first have to send out balance to push to the other side to be able to have that balance be pushed back to your channel side. And just to conceptualize this thing, you have to have spent money to be able to receive it. Or you have to have someone commit capital to open a channel to you so that you can receive money in the future. Try telling that to someone using PayPal or Cash App, that you first have to spend money to be able to receive, which is like super weird and kind of alien to everybody installing a Lightning wallet for the first time. Because why would I have to do that? The workaround for this thing that was introduced in the Lightning ecosystem is a thing called LSP, the Lightning Service Provider, which pretty much offers the solution to this problem as a service, where you can go to and request, could you please open a channel to me for these many sats and let me receive through that. So you basically have to have another service provider that gives you the ability to receive funds, which is you have to pay to be able to receive. Still weird, but I guess workable in some sense. But there's a cost to it, because they have to commit capital, they have to open a channel to you, and money is not free. They commit to opening the channel, and their money is in there. If you never use that channel, they basically committed capital for no good reason. If you go offline for 4 months and don't use that channel, the capital is just sitting there, idling around, not doing anything. So there's a cost for the service provider, which they charge the end user for. And also the question is, how far can you scale this thing? In a sense that if everybody in this room requests a channel for $1,000, so some service provider commits $1,000 to each and every one of us, the cost is not that bad. But scale this up to the city of Vienna, and everybody wants to be able to receive $1,000. The costs add up pretty quickly, and there is only so much Bitcoin that these Lightning companies have, and only so much to ever exist. How much can you offer in unproductive channels in receiving ability to random people? And how much do you need to charge for that if it's not productive? This is a real tricky thing. And imagine you're a small startup trying to build such a Lightning LSP. You need a hell of a lot of capital if you ever become even slightly successful. Because this cost of having to open channels to people so that they can use your application is never going away. It's intrinsic to the protocol. And unless we make some crazy innovation of multi-party channels, which is moon math basically, it's going to stay this exact same way without any way of improving it. And I think these four reasons, chain data, gossip sync, backups, and the liquidity problems are the reason why Lightning in the end consumer world never really took off. Why the custodial solutions like Blink or Vault of Satoshi are so successful, because the issues with having it self-sovereign, self-custodial with your own node on your phone are just too grave, and the UX is just horrible enough so that people are not willing to go self-custodial for their Lightning spending money. But there's a new way now. And to an extent, it works around most of these issues. And the trick is to just not use Lightning. There's a thing called Submarine Swaps. You might have heard of atomic swaps, where you can atomically, meaning it either happens in full or not at all, swap between two assets. It was firstly the atomic swap concept pioneered by, what's the name of the Litecoin founder again? Litecoin, yeah, not Bobby Lee, that's the BTC China guy. Anyways, it was firstly pioneered by the Litecoin people and some Bitcoin devs that they swapped atomically between Litecoin and Bitcoin. And the submarine swaps are an adaptation of that, where you do atomic swaps between on-chain Bitcoin and Lightning. The first one to ever use that submarine swap concept in a production setting was a wallet called Moon. And their old slogan, one wallet, all payments says it all, where you have a unified balance, which is your on-chain UTXOs, and you can receive and send via Lightning. It feels native, as in you can't just show a Lightning invoice, you can't just pay a Lightning invoice, but actually it's real on-chain UTXOs behind the scene. And so they could offer Lightning without having to run a Lightning node on their phone. This entire atomic swap, submarine swap concept works because of the HTLCs we had way back in my first diagram. Every payment on Lightning is this hash time lock contract, and these hash time lock contracts we can also do on chain. And therefore we can have truly atomic swaps between Lightning and on-chain Bitcoin without introducing any kind of trust. And you mitigate basically all of the issues you had with the Lightning implementations, as in, yeah, you still need some kind of chain data, but it's not as critical anymore, because if some provider doesn't show you UTXO, use a different one, there it is, doesn't really matter. You don't have the gossip problem because you effectively do the trampoline routing. You don't have the backup problem because your keys for on-chain wallets are deterministic, your 12 words, and you can recover them just fine. And liquidity is a non-issue too, because you don't have channels in this submarine swap wallet setting. The one issue that Moon had though is they still used on-chain UTXOs for their swaps, which you can imagine doesn't scale really nicely. And they had a huge user base before the ordinals, runes, fee spike happened, where they basically all lost most of the user base because it became prohibitively expensive to do an on-chain transaction for every Lightning payment you do. Now, with our cheap mempool fees, it would be feasible again, but most of the user base has moved on by now. But still, real pioneers with this concept. So now a little bit about where we saw our potential in connecting the Bitcoin layers via these atomic and submarine swaps. And I want to talk a little bit about how they work exactly, before talking about how you can apply them for all the different Bitcoin layers. First of all, you have the Bitcoin Mainchain, obviously. You have the Lightning thing we just talked about, which you can connect with the Submarine Swaps. You have the Liquid and rootstock Bitcoin adjacent federated sidechains. But you also have a bunch of cool new Bitcoin layers coming up, like for example, Arcade. You have the Spark thing coming from Lightspark. You have a bunch of BitVM rollups coming, and they can be connected the same way that Lightning and Mainchain UTXOs have been connected by Moon. So we take this HTLC concept I briefly talked about in the beginning, and with this primitive, which sounds super simple, HTLC stands for hash time lock contract. That's pretty much the key to the castle. That's the one primitive that Lightning has. It's the only primitive that Lightning has. It's literally all it can do. But even with that constraining factor on Lightning, that it's the only thing it can do, we can still make quite a few things possible. So we have a hash time lock contract, hash lock and a time lock. And this basically every single chain, every single new Bitcoin layer, every single thing, altcoin chain, apart from Monero, has hash locks and time locks. So these are very underlying primitives that pretty much everything supports. And hash lock, just to make the concepts clear, a hash lock is when you have some data, you hash it, and with that hash, you commit to it in some address, in some contract, and by revealing the pre-image, the thing that was hashed, you unlock the coins. Time lock is basically coins are locked until this point in time. Could be a block height, could be a Unix timestamp, something like that. So we at Boltz took this concept, and this slide is look really similar to the Lightning routing example that we had before, but we took basically the Lightning routing concept, but we changed it in a way that you have Alice with the Lightning node that sends an HTLC to our Lightning node, and we forward that HTLC not via a next Lightning channel, not via the Lightning network, but we forward this HTLC to, in this example, a Liquid address. And the exact same way is possible that you go from a Liquid address, a Mainchain address, a rootstock address to Lightning via HTLCs. The same way that you forward an HTLC as a routing node. Hash time lock contract comes in, hash time lock contract goes out on a different channel. The exact same way works for any chain, any new Bitcoin layer 2, if they support hash locks and time locks. And this is pretty much how we did it on the Bitcoin chain. Same thing for Liquid. They have the exact same scripting, that you have a Bitcoin script that does enforce the HTLC. You have just to briefly go over Bitcoin scripting, you have an op-if, which goes into your hash lock, where you have the pre-image hash, basically the commitment to which Lightning invoice you're talking about, and then a public key of who can spend in that scenario. Then you have an else path, where you have a block height, and then the opcode CLTV, which stands for check lock time verify. It's basically for checking the lock time requirement, which literally says, if the block height that we are at right now is greater or equal to this value, it's true, you can spend. Different public key, and then we check a signature. With this simple script, you can basically forward Lightning payments from and to Lightning to the Bitcoin UTXOs the way Moon did it. That script was for Segwit v0. And with Taproot, I just briefly want to touch on, there were some optimizations we did with Music 2, so signature aggregation, which makes the whole thing vastly more efficient in the happy scenario. And we don't have an op-if and op-else branch anymore, but we ripped the script into two parts and built a tree of scripts. So what you can do in Taproot, and this concept will get important later, is that instead of doing ifs and else, you can rip the script apart into two, meaning that the if branch and the else branch are now two separate scripts. And when you want to spend from either of them, you basically prove to the chain that this script was included in my tree. You show the script, and then you can spend it the exact same way as if it had been an else path. It's like an efficiency optimization and gives you smaller transactions while still having the option to spend either of them, whichever is applicable to your scenario. And with that combination of either aggregated public keys, meaning you can just sign together without having to enforce any script, or script path, as in you have the same script capabilities but ripped apart into the tree, we have a more efficient way of doing what Moon started way back in the day in 2019, 2020. This is basically just a major optimization on their approach. And this thing that we did was basically meant for Lightning node operations and handling. Imagine you are a merchant, you have your set of channels, everyone pays you, you get channel balance moved to your side from different sources that just buy stuff at your store. You eventually run out of inbound capacity of balance that can be pushed to your side of the channel, and at some point you won't be able to receive anymore. So we built our Submarine Swaps so that people can send us a big Lightning payment and receive their coins back on the main chain, back on Liquid, on Rootstock, wherever they prefer, and handle their Lightning node without the need of buying inbound liquidity or opening channels to people over and over again, but to be able to reuse the existing channels and move balance around to wherever they need to. That was our initial design goal. But then something unexpected happened, and wallets started to use this exact concept. To name a couple prominent examples, the Bull Bitcoin one, the Aqua wallet from John Free, and Misty Breeze use our swaps from Lightning to Liquid to allow you to have a Lightning wallet in an easy and seamless way on your phone. This is basically the exact same thing that Moon did back in the day with on-chain UTXOs, but this time with the Liquid sidechain. Because Liquid itself has some advantages. It's not used as much as the main chain. It's federated and therefore can just hard fork whenever it needs more capacity, and has faster blocks, but even down at the bottom of the stack, it works really similar to Bitcoin as in UTXOs, and devs are somewhat familiar with it and how it works. There's only a small learning curve. And what these wallets did with our swaps is that they basically add a Liquid wallet and then expose in a very user-friendly way to swap either from Lightning or to Lightning directly in the UI, which makes the thing super seamless, and it feels like a properly done Lightning node implementation running in your phone. But behind the scenes, it's all these Submarine Swaps that give you the ability to send to Lightning and receive via Lightning whenever you need to. In the end, not intended by us, this was just like a side effect of there is such a desperate need in the industry that people want to offer Lightning in their applications, in their wallets, but it's just so hard to do that they were grasping at straws, basically going for the trade-offs of Liquid and accepted it being federated and all the downsides it has, just because they wanted something that's not going through the pain of syncing the chain, syncing the gossip, doing backups properly. It's like horrible as an application developer. This is super easy to do, which is why people opted for it. And from what we can tell, especially the Aqua wallet and the Bull Bitcoin one find quite a bit of adoption because it's trivial to use. And as an end user, in the happy path, you don't notice any issues. It just works. And just works is a really strong sell compared to sync your chain, wait for half an hour, oh no, rapid gossip sync failed. This thing just, you open it, wait for 5 seconds, like an on-chain wallet, and the Lightning just works. There is such a need that people want to do Lightning because in the end, all of the Bitcoin ecosystems we have right now, from the Bitcoin chain, Liquid, Rootstock, Arc, Fedi, Cashew, Spark, everything gravitates to Lightning. And right now, what's happening is that different products, different applications, different users pick different places to store their coins, different ecosystems that they prefer to use. But when they want to cross the chasm, go to a different ecosystem, the common language, as Roy from Breeze coined it, is Lightning. In a sense that if I use Aqua with my Liquid wallet behind the scenes, Dani has his Lightning node at home in the basement, someone else uses Cashew, everything speaks Lightning. Everyone can just pay each other and transfer value via Lightning. Let it be via Submarine Swap, via native channels that they have, or via Fedi Cashew gateway to Lightning. Everything talks to each other in Lightning. And I think these days, it's not the smart thing to do to ignore it, because despite it not being crazy popular when looking at the network and the engagement, it's still something that people will request when you build on Bitcoin. Because if you want to go to any other ecosystems, you will need Lightning, because that's the way that allows you to cross over to a different silo of users and to allow your application to go to some other place where the coins want to be transferred. So when you want to do Lightning without the pure pain of running an actual node on your phone or your application, but you're not fine with the trade-offs that Aqua or Bull Bitcoin made when it comes to where the coins actually are, let it be Rootstock or Liquid, there is a new frontier now, which I want to touch on, and they are called Arcade, so Arc, and there's also Spark from the Lightspark team in the States. And these are new actual Bitcoin layer 2s where you have full self-custody, which also interoperate with Lightning in a beautiful way. They are not Lightning themselves. They don't run nodes, they don't have channels, but they allow for the same atomic submarine swap concept without any compromises when it comes to the custody of users' funds. I want to touch on Spark a little bit and talk about what Spark is. Spark by design is a so-called state chain. And just to break down the concept of a state chain really briefly and from a bird eye view. Imagine you take a Bitcoin and send it to a 2 out of 2 multisig with the Spark operators. The Spark operators are also a federation of multiple entities, and you send your coins in a 2 out of 2 multisig with you and the Spark operators. What you sign before that, actually sending the coins, is a so-called unilateral exit transaction, where you can forcefully get your coins back. And the state chain concept means that the transaction to force your coins back has a time lock. When I put the coin in Spark, the time lock is 1 week. When I transfer the coins on Spark, the time lock is 6 days. Transferred again, 5 days. It's a decrementing time lock that goes lower every time it's transferred, meaning the last owner of the coin is the first one that can exit, meaning the last owner of the coin actually gets the on-chain UTXO back. So you have a gigantic cut through of you put coins in, transfer them 1 million times, and the last owner gets the UTXO back. It's basically a cut through of what happened in the middle. This allows you for huge scalability because you don't do an on-chain transfer every time. You just settle when the expiry hits. And if there was one transfer done in the meanwhile, or 1 million ones, doesn't matter. The only thing that is happening on-chain is the exit transaction of the last owner when the time lock is over. Issue being that the operators have to co-sign every single transfer, but you still retain unilateral exit, meaning that when you are the last owner of the coin, you can force your coins out. Maybe not right now, but there's a time lock on it. And when the time lock hits, let it be a day, a week, a month, you get your coins back always. That's also a concept in Lightning where when you force close a channel, forcefully close it, unilateral exit in Lightning, you also have to wait potentially for a day, a week, 2 weeks to get the coins back. So unilateral exit with time locks is not unheard of. And Lightning works in Spark with the so-called Spark Service Provider, where they have a similar submarine atomic swap concept that you can go from a Spark leaf, that's what they call their coins in Spark, to Lightning and back in a very easy way. The other new frontier is Arcade. And Arcade is the implementation of a protocol called Arc from Arc Labs. There's also a second implementation of a company called Second, which is called Bark, but they are not on mainnet yet, so I want to focus on Arcade. And the concepts, the high-level concepts transfer over one-to-one to the second implementation. So Arc works differently than Spark. There's not this state chain of decreasing timeouts. It's basically a gigantic UTXO batching engine. When you have one of these batch outputs, the unilateral exit out of the layer 2 of Arcade works in a way that this batch output, which is like one output of one Bitcoin transaction, is a potentially ginormous taproot tree. I briefly talked about the two different script paths we have in our swaps, of one with the hash lock, one with the time lock, and you selectively reveal which one you want to spend. They took the same concept, but use it for a different purpose. As in, you have a gigantic batch output with a deep taproot tree, and at the very bottom of the tree, the leaves of the tree, you have the actual funds of the owners of the coin. So this Arc batching engine basically aggregates everyone's coins, everyone's UTXOs into one output. And from this one output, you can either spend together with the cosigner, the Arc operator, or after a delay. So this unilateral exit concept, where you can force your coins out of the Arc, still applies after a timeout, or if you cosign with the Arc operator, so cosigning also exists in the same way as Spark, you can transfer whenever you want to. And this Arc, and the idea behind Arc, why nobody did it before but only now, is a thing called connector outputs, where you basically can atomically hop from one batch output into a next one. So if there is one batch output, you have your leave in right now, and there's a new batch coming afterwards. You can just go from the last batch, forfeit your rights to that one, and atomically get new rights to a new leave for the same amount in the new batch. Which means you never have to leave the Arc if you want to transfer. You just join a new batch transaction to transfer coins. Yeah, as I said, unilateral exit is still given. So if you just want to get out forcefully, or the Arc operator refuses to cosign with you, you just have to sit out your delay, which could be a day, a month, a week, whatever. Depends on the configuration. That's completely arbitrary. You just sit there and then broadcast your transaction that reveals your leave with your coins. And you sweep it back to your wallet and your coins are yours. So there is no way of an Arc operator stealing from you. Worst case, you just have to sit it out and wait for a little while. The one thing that Arc retains from the Bitcoin chain as like the first layer 2 that I've seen is it has the scripting capabilities of the Bitcoin chain one-to-one. Meaning that in this batch transaction down the tree, here you can have a Bitcoin script. This doesn't have to be just your public key. You can have an arbitrary script in there, meaning that in here you could have a multisig 2 out of 3. You could have a hash lock, a time lock. Basically everything you can script on the Bitcoin main chain, you could also do in your Arc leaves. Meaning that if you want to do, for example, things that we used to do on Bitcoin back in the day, as in escrow contracts or fancy things like DLCs, everything that was built for the Bitcoin main chain transfers over to Arc one-to-one, with the only tiny little change that in the cooperative path you want to assign +s, meaning plus Arc operator, and add an exit path with a delay to forcefully get your coins back in your neutral exit. If you add those 2 minor things, you can transfer basically everything you've built for Bitcoin one-to-one to an Arc. Doesn't even have to be Arcade, could be the Bark of Second. This capability being retained is a property inherent to Arc designs. And we've partnered with Arcade to add our Lightning swaps to basically the reference client. It wasn't added to the layer 2 because it inherently has the scripting capabilities. We just partnered with them to be like a first-party provider for the Lightning integration. Meaning that from day one, from the day that Arcade launched, you could just go into Arcade and out via Lightning, via the swaps that we already did for the other Bitcoin layers. And it was there from day one. People liked it and it's super easy to do. And we can do these HTLCs that we already did on the Bitcoin main chain and Liquid and Rootstock the exact same way on Arc. Meaning that the script, the hash lock, the time lock, the music too, it all transferred over one-to-one. The only thing we actually had to add was the happy path, the co-signing, if everything's all right, and the delay path that you have away at time lock, after which you get your natural exit rights. So yeah, so basically, in conclusion, what I was trying to get across is that actual real native Lightning on a mobile setting or even anything that wants good UX is not feasible. If the thing you actually want to do, your focus is not just Lightning, you'll have a horrendous time trying to get it right. It's getting easier, it's gotten easier over the years, but the inherent flaws of Lightning are never gonna go away. What I do see the future in is something like Arcade, a new kind of layer 2 that interoperates natively with Lightning. And it's the same thing for Spark. Like this huge venture-funded company in the US bet on Lightning on day one. They built their whole layer 2 with Lightning from the get-go because it allows people to interact with the new layer natively without having to go through on-chain transactions, weird onboarding procedures. You can just swap into it. And people have been using Arc and Spark already as their Lightning wallets, where you don't actually run a node, but abstract it completely away from the user, as in the coins are still in an actual layer 2, where they retain full self-custody, but interact with Lightning seamlessly via atomic swaps. The trade-offs to having a third-party service provider for your blockchain data, your gossip, your Trampoline routing are not that different compared to a swap provider, but it gives you a vastly superior experience because everything underneath you can optimize for your needs. Maybe you like Liquid best, sure, you can swap to Lightning. Maybe you like Spark best, swap to Lightning and back and forth. Same with Arcade. You can pretty much pick your engine underneath, but everything works with Lightning seamlessly via these Lightning swaps and the interoperability that they give you. So yeah, I want to give a quick demo of like how seamless it works. And if someone has questions, please feel free. In German, English, both is fine.